Now, keeping all of that in mind, I'm going to close down all these files. I'm not going to save any of them in here. How do I support this deck? I've got some unique features here in the middle of the deck. I've got some posts that are coming through that are going to be supported above. How do we actually approach a project like this in order to provide the framing for this? Well, some of the considerations are this. Remember that the joists run in the opposite direction of the decking. So I'm going to sketch on top of this, and then I'm going to show some very quick ways of being able to draw this. And what I'm simply going to do, and I don't recommend this, but it's to give you an idea of how we'd actually approach the structure. And I'm going to go into a layer that I'm not using right now in this, and we're going to basically draw the framing. So I'm using the polyline command, and I'm simply going over top of the edge of the framing, or the edge of the upper deck right now. And this will help me with some of the basics of what I know. So there we go. Let me go right to here and right to that edge. So all the beams that I'm going to have are going to be offset by 2 feet. I'm always going to max that out as best I can. So I've drawn the edge of that deck, and I'm going to offset that 2 feet. That's the configuration of my beam because it runs in parallel to the actual decking, and the joist will rest on it to support the framing. Now, certain areas in here don't do what we just did. I've done this because it's a very simple way of being able to outline where that beam is, but this portion in here, the beam doesn't go in this direction. It goes lengthwise down to here. And same with this one in here. So that's more or less where the beams are going to go. And the beams will support the joists. The joists run in this direction, up and down. And they'll be going throughout this space, all along here, all along here, all along here. Okay, so what rules do we know, or what information do we know? Well, the beams shouldn't be any further apart than, that 12 to 14 foot sweet spot. So let's see what happens when I do that offset. I'm going to offset by 12 feet this line. And you can see that I've been able to, in most cases, like along here and along here, be well, but right here I'm getting to that 13-foot mark. So I'm not sure whether I'm going to need a beam in between or not. Here it's obvious. I'm well beyond the 12-foot mark. So I may have to put in a smaller beam along that center section just to satisfy that directional value and to make sure that I've met that 12-foot offset, because the beams can't be separated more than that. Otherwise I've got too much weight. I've got too much load that's going to be coming down on that. So it's a matter of understanding some of the previous lessons that we've had to be able to understand what I'm talking about. I'm going to do the same down in here. What you did notice, though, probably is the fact that I've perfectly placed my pergola right on top of the corners of the beams, and that isn't by chance. That's just by experience. So let me do the lower deck here. Now I do have already that as a polyline, so I'm just going to offset that as a polyline. There we go. I'm going to change that color to my deck structural, or I had it as a steel framing, foundation steel. So there's going to be a beam along this edge that will support all the joists, and there has to be one at a diagonal. Now I can point those out. I can pull these right to the edge and make a point, but I do know in this particular case what I need to do in order to frame this out nicely, how I'm going to put in the actual wood framing, but I could basically make a right angle there. And I'm going to offset that one. Now, as we've discovered before, I don't need a beam in the same direction as the framing or the decking that's going to go there. I need it to run opposite. So this piece actually gets extended out to here. It won't let me, so I'm going to have to do it the manual way. I know that's a 45-degree angle, so I'll type in, I don't know, about 4 feet, less than 45. There we go. And then that's easy to bring back. So that's where my beam's going to go. So I have a beam. You can see I have some strained configurations of beams here, but I need to be able to support the joist and the overhang. I know I'm going to need a beam in the midpoint. And each of these corners is a column. Remember what column spacings are going to be? Approximately 12 feet, 12 to 14 feet apart. So I start at one end. Now remember we offset that 2 feet inwards. So my first column, if I draw it in, I'm just going to guesstimate approximately here. It's 2 foot in. And then my columns to support that are going to be on corners. So every corner will get a column because that's where two beams meet. I've got to support them at the and then 2 feet inwards from there, which is approximately here. So I've quickly designed this. Now there's going to be some nuances here where there's a staircase. That beam actually should be only about a foot away or near the edge of the beam, and we can adjust that, or near the edge of the deck, we can adjust that. What about in this direction? Now notice where this intersects this. There's a slight variation in here in this corner, and that's because of the way it's framed. So I've got a couple of choices here. Let me show you what I mean. To make this efficient, I'd really like this beam, which I can't move any further back, to align with this series of corners. I could put an extra post, but it's extra work, and the dynamics of it all just makes it a lot more. So I'm going to change this line. So I've clicked on it and I've selected, or I've typed in explode. So that changes it from a polyline property to a non-polyline. I'm going to do the same here, and there's a reason why. It's because if I connect or do a fillet between a polyline and a non-polyline, it all becomes a polyline, which sort of defeats the purpose here. And I'm going to do this. I'm going to join those two. I'm going to look at it and say, I want that column here. Well, if I want that column here, I'm going to move this. Well, fortunately, there's a staircase here, and I got to remove the beam closer to the staircase anyways. So I'm going to move this line, which inevitably will move that and this, but let's just leave that for now. And that, these two have to line up from this corner here, where they meet, down to that corner. So that beam will provide the edge support. It's not that maximum 2 feet, but that's okay. We try to max it out if we can, but if we can't, we can't. And now I'm going to move these two items from their position inwards. And that column could go right to the edge. It won't make a difference in this particular case. And I'll have a fillet. That's such a short column, or I should say that's such a short beam. Whether I have this 2 foot overhang or not won't make the slightest difference. So leaving it out there, space in that direction, is not a bad thing in this particular case. Again, a lot of these things, they'll come from experience, which is kind of tough to teach in a single lesson. It's more of trial and error, and after a certain time, you kind of get the hang of it, and you'll understand how it frames. Now, the framing down below here, how often do I have columns? Well, I do know that I have columns on every corner. So let's go back to this image. I'm going to put a, let's see, I'm going to copy this from this corner to, I know I've got a column here. And I know I've got a column somewhere here about 2 feet off the edge. I could line it up with the one above it. Now what about this distance? Let's measure it. So I'll go into Tools, Inquiry Distance from here to here. And it looks like it's 40 feet. If I divide that in half, they're 20 feet, too big. If I divide that into thirds, it's approximately 13 foot 6. That just might work. If I divide it into quarters, it's 10 foot spacings. So again, there it's a design decision. Do I want to line up columns from row after row? Do I want to make some changes? What do I want to do? Well, I'm going to show you what my sort of result of all this is. This is the layout I came up with, and you'll notice, like I've drawn the new one over top of the old one. It's pretty much on. So I have a slight variation in some of the distances. Those columns are pretty much where they ended up being. I'm going to have to provide some extra beam support for this opening, and I'll discuss that in greater detail. And then I had to put in a column or a beam in the middle because remember this distance exceeded our 14-foot length. So the decision I made was rather than just put something in the middle with two columns and a beam, I'm using an existing column that I have to build anyways, and I'm just adding a single column and extending that one beam. And therefore I've reduced this overall span to a required amount without having to add that much more to the structure. It's one more hole for a sonotube, and the beams just continue. So it's an easy layout. The beam or the columns below, all I did was line up the ones that were above, that were mandatory. I needed to have that one there, so I lined up one below that. Oh, sorry, that one didn't. This one I lined up with that. That I lined up with. I had a corner, so I had to provide an extra column there because I needed to support this opening. And that's how I got that particular beam. Now, this is going to be the first time you're ever going to do this type of work, this structure. So I don't expect you to get it right, but I do expect you to attempt it. And this is where it's very important that once you've kind of done your layout, you're going to present that to me. I'm going to mark these things up, scan them, and send them back to you with the recommended layout. So not to worry if you're not quite getting it, but this is how we approach the whole problem of creating a post and beam construction and basically laying out our structure.